Okay, so we just discovered a thing that if we take this funny red, green, blue color mode and just replace it with our usual red, green, blue color mode in parentheses, that this thing still works exactly the way you think it would. So if we rerun this, and I set the iterates down so it just takes nothing. But of course the image you get out is super tiny. So you get this really tiny little guy, but at least the color scheme still works, so we could turn the resolution back up and get a little better. We might note that the picture is getting really, really poor quality down there, right? Because it doesn't have very many pixels. So if we wanted better quality, what would we do? Yeah, turn up the number of pixels. What's that going to do? Make things take way longer. Yeah, and actually, that is a fun thing to do. I highly encourage... I'm going to put this thing on canvas. I really encourage you guys to start running this thing in the background on one of these computers and just leave it running. And we'll come back tomorrow, or we'll come back Tuesday, and maybe it'll be done.
Maybe.
So what we'll do is we'll run a little experiment where we each set it to something different, and when we leave the lab, we'll just turn them all on and walk out. And maybe people won't use those computers on Friday and notice the processors are all bogged down. And maybe Tuesday we'll be able to find some cool files. Yeah, the only reason I'm doing this at all is that there's a really good possibility that campus will be closed on Friday. And, of course, they should all be done by Monday. I've only run a couple of these that took longer than that. And I was doing things like making movies out of Zooms or something, and those take a long time. There's some super cool YouTube videos for these things. Yeah, I would highly recommend Google it or throwing Mandelbrot Zoom into YouTube.
Can we also change the style of Mandelbrot? Like, instead of having, that specific picture, we can change a few numbers and have it.
Yeah, so if you want to create a different image, right, one thing you could do is you could fiddle with the X mins, maxes, and the Y mins and maxes, right? And that'll kind of let you zoom in on one little area. So you might want to fiddle with those a little bit. Another thing you'll need to do as you increase the image size is you'll need to increase the number of iterations as well. Does that seem obvious? Basically, the finer your image is, right, the deeper you can zoom into one of those little fjords. And the deeper that fjord is, the more iterates it takes to get out of it. Yeah, you probably want to increase the... so if you make this, say, 400 million or something, right, you'd probably want to increase the number of max iterates to 5,000 or 6,000 at least. Cool? And that'll make things take a hell of a long time. If we were doing a good job coding, right, we'd figure out, like, where is the Mandelbrot set in there, and that middle white part, we'd, like, take a big chunk of that out and not iterate on it at all. Right, but that takes, like, a bunch of if statements and whatever. RAM's cheap. Cool? The other thing I want to show you is this silly progress completed thing, right? So the way I'm making progress completed is I'm taking the Y, right? So how far down the image are you? Like, which row are you on, basically? And then I'm dividing it by the image Y. Oh, sorry. That's going to give you the percentage down the picture you are. Right? So I really probably could have done a smarter thing here. F it. So I'm taking percent progress towards getting to the end of the image, right? And then I'm multiplying by 1,000 because I want to keep a single decimal place, right? So this is going to be like image divided by, or sorry, Y divided by image Y is going to be like 0.6 or 0.9 or 1, right? So I'm multiplying by 1,000 to make that into 3 places in front of the decimal. And then I'm making an integer out of that in an attempt to, truncate the rest of the decimals. Right? So that's this whole part here. So this guy's going to be, if I take that divided by 10 out, that'll print 1, meaning 0.1% complete. Or it'll print 500, meaning 50% complete, like 50.0% complete. So I'm putting the divided by 10 to put the decimal point back in. You guys with me on that? What type should that variable be? Yeah, should be a float, right? Okay, so in an attempt to get that thing to print, I'm making 4 print commands here, right? I'm going to print just the percent completed, and then I'm going to put a float string in, and I'm going to pass the float string the idea of progress. I'm going to do a percent completed with a percent %d, which should stand for like decimal, like number-y data. That would work for an integer or a float. And then I'm going to pass it progress. And then I'm just doing print percent completed and also this progress number. And then print percent completed and also this image size thing. And then if I really... oh, what the hell. I'm going to run this and see what those 4 do. PowerShell. Pi. See that they're not the same?
So first of all, percent D, I'm pretty sure just needs a digit, which it only is.
Okay, so what I'm getting here is I'm getting a float, right? This one seems like it's acting like it's just an integer, and then the other 2 are working in the same way, right? So apparently passing progress or just the progress formula gives you the same answer. That's good. It should. But why the percent %d passes progress as an integer is a little funny. So what if I put in 12.5? Like they should all print 12.5 now, right? Or maybe 12? Okay, so the percent %d apparently does just the integer part, right? Cool. So when you Google this, you will find documentation that tells you the percent %d will do either an integer or a float. And they're lying.
And I was always told it's just integers.
Yeah, I thought it was just integers too until I Googled it to see what was going on. I found somewhere on the internet that said that it was integers and floats, but it is in fact just integers.
And the percent float just automatically takes it to 6 decimal.
Yeah, and for some reason the float one automatically adds some stuff which I'm not a huge fan of.
It just takes it to 6 decimal.
Yeah, it takes it to the usual float spot.
It seems like
These ones are much better somehow.
it's like those percent ones are like casting them forcefully somehow, where the progress and the other one are just like, here's what we got.
Yeah, that's exactly what's up. These guys are doing some kind of variable casting. And I said that Python doesn't really do variable typing, right? But Python apparently does some variable typing when you're trying to pass variables into strings.
It's printf. Printf is just a thing that's like it's something.
Yeah, it's formatting for the print command is a
Yeah.
little funky.
I think everyone uses the exact same printf, which means they go off a chart that's usually kind of foreign, depending on the language you're using. Because it's like, oh, I'm using Java. Oh, printf looks very different from everything else in Java. And
Yeah, so there's some funkiness with the print command. What else? You guys cool with this? Questions, things? Okay. Another stupid trick that you should know, because it's fun, is that you can use that percent %d thing to change file names. So if you wanted to run through a for loop and make a bunch of files, like if you wanted to make a movie, right? One way you could make a movie is by doing something like this, where you create each frame based on some variable. If that variable's iterated, every time it goes through, it'll save a new one. You guys cool with that? So you could use this to make a movie of the Mandelbrot set. Let me show you some movie of the Mandelbrot set. This is maybe my favorite video that... Oops, not that. This is my favorite video that exists on YouTube, I think. So this is just falling into the Mandelbrot set. And the way they created this, right, is they made a program like I was just talking about, where it names each image a little differently, right, based on a for loop. And then they changed the bounds of the window. Right? And they made the bounds of the window just a little tiny bit smaller every time. You guys are totally mesmerized, aren't you? Yeah, this is a great video. One of the things about this video that should be noted is you can't make a video like this in Python without spending a bunch of time screwing around, because the floats aren't precise enough. Right? If you look at the title of this video is zooming 10 to the 227 power. Yeah, so what you need is you need to write yourself a... Oh, nice. There's a counter in the corner. You guys see this counter?
Yeah.
So it's now reaching 10 to the minus 90. And if we scroll a little ways ahead. Good question for you. How long could this video continue for? Yep. This is a rabbit hole that goes all the way down. Right, which is why the computer's going to have a hard time. So what you would spend most of your time doing in trying to make a video like this is not writing the Python code to get the images generated. It's writing the Python code to keep track of the new variable type you're going to need. That's going to be like a float with arbitrarily many decimal places. Right? So you're going to have to use some kind of screwy array to keep track of these things or something. Like you're going to write you have a float and what's the longer version of a float? Double or a long, depending. Longs for integers. So float, double, you'd need like a mega double to keep track of this stuff. Because we're all just sitting. This is great. I highly encourage you to watch this video, all 17 minutes of it. I won't spoil the ending. There is something cool that happens at the end.